Welcome to Study Loop.
This is chapter 27, problem number 10. We are trying to calculate the flux through a given area. Flux through a given area would be the dot product of the magnetic field and the area vector. So then the magnetic field vector is given to us as 0.2 I hat plus 0.3 j hat minus 0.5 k hat. Dot product. Now we have to calculate the area vector since it's a square and the length of one side is given to us. We know that the area of a square is going to be L squared. So L is 3.4 times 10 to the power of negative 2 meters. So we did the conversion. So L squared would give us the area. And now we need to write it in the vector form so that we should figure out what the direction of n hat is in this case. So the problem says that it's the surface is on the xy plane, so z equals 0, which means the n hat, which is the direction of the normal vector, has to be along z hat. So which means if it's along the z direction, notation, let's stick to the notation ijk notation, then it's going to be k hat. Now we can basically do the dot product. Let's remember this means we're multiplying the first term with this one and the second term plus second term, again multiplied by the k hat component, the third term multiplied by the k hat component. As you remember, I hat dot product k hat is going to give you 0. J hat dot product k hat is also going to give you 0. The only term that survives here is this multiplied by the area vector then, because k hat times k hat is going to give us 1. Then the flux is going to be equal to negative 5.5 times 10 to the power of negative 4 Tesla meters squared. If we were to calculate the magnitude of this flux, as you know, we're just going to take the absolute value of this negative value. Then it's going to be equal to 5.5 times 10 to the power of negative 4 Tesla meter square.